Tonight we're going to be going over multivariable equations in the SAT. This is such a big thing because I remember when I first really started looking into the SAT, and actually, I mean, when I first started looking into the SAT, also when I first started trying to teach the SAT, multivariable equations was kind of like the big thing that I knew going into was going to be probably one of the hardest parts to teach of the SAT and also to do of the SAT. Because multivariable equations, it's this kind of thing that like nobody I think really knows how to do. And people who do know how to do it, most of them, they just teach like this really long, winded explanations of these problems that I think is really bad and doesn't really help anyone at all and just forces you to get even more confused most of the time than you would be otherwise. So in this video, I'm going to try to explain these a lot easier than you will see from most things online. And I think a lot of you will find this really, really useful. What I define as a multivariable equation in Desmos, or also I just call them constants problems sometimes because I think it's a little bit easier, but regardless, is a problem when there's more, actually wait, I just realized I put this entirely the wrong way. Yeah, it's when there's more variables than you have equations in a problem, like that instead. So when you have more variables than you have equations. So for example, if you have these two equations in a math problem that you have to use, you can just solve these with regular Desmos, which I won't really be focusing too much in this video. Just if I was to solve it, I could just do like 2x plus 3y is equal to 5, and then x plus 8y is equal to 2. And then I can just see here, they intersect at this one place. It's a really long number, but regardless, it's just at one place. So that's pretty good. But what when you have more variables than you have equations? Well, the first thing you need to do is understand that when you have more variables than equations, it technically is not supposed to work. Like it should not work. If I add here, for example, a third variable, like if I put z in here, and here I guess too, this does not mathematically work to give you an answer because you must have as many equations as you have variables. We have here 1, 2, 3 different variables, or unknowns, you can call them as well, but we only have 2 equations. So theoretically, you should not be able to solve these 2 things. And you cannot solve them. There's no way in math to solve them. But there is a way to solve it on the SAT because typically what's going to happen when you get put into a situation like this where you have more variables than you have equations is you're going to be given some other piece of information to solve it as well. So you might be given this, and then you might also be told that z must be like greater than 2. And the thing is, when you have that extra piece of information, it's not as good as a equation, obviously. It's not as much information here, but it still is really, really good because it like kind of narrows down the amount of things that could be the right answer. And typically what happens is when you have this other piece of information, it's enough for you to solve the entire problem. The other piece of information can also sometimes be like x is all real numbers. So x can basically be anything. That also can work. And this is really good because this essentially makes it so you only have 2 variables functionally. So that's pretty good. And it can show some other ways as well that are a little bit more niche. But these are the 2 main things. Either saying going to be one variable is going to be greater than a certain number or less than, or you could say that something is all real numbers. And now the way to solve it will almost always involve Desmos. This is another thing I've seen a lot of people online talk about how to solve these problems. And it's kind of like this thing where a lot of people, for some reason, they just don't know the Desmos way to solve these problems, or I guess they don't want to teach it or something, because I see a lot of people going through these problems completely manually when you really do not need to be. And to be honest, I was in the same position myself. I used to not know that there is a way to do these with Desmos. So I don't completely blame these people. But regardless, if you're doing all these problems manually, you're definitely doing something wrong. So the simplest way a problem like this can show up is something like this. We can count here how many different unknowns are there. There's 1, the x's, 2, and 3. So yeah, seeing 3 different unknown things. But how many equations are there? There's only 1 equation because there's only 1 equal sign. So there are 3 different variables, but only 1 equation. Also, in case you didn't realize at this point, I'm basically saying variables and unknowns as like interchangeable. They're not technically interchangeable, but for the sake of this call, I'm just going to consider them interchangeable because I've probably said them interchangeably so many times already. Here, again, we have a problem where it's more variables than we have equations. So we have x here, a, and then b. So I guess like 3 different variables, but only 1 equation here as well. I start off by just putting it in for ax plus 2, and then 5x squared minus bx plus 7, and then equal 15x cubed minus 2x squared plus 13x plus 14. And then what I can go ahead and do is make x into x1. And then if we had a y, we could put y1 here as well. But yeah, let me just do all of those. And then I have to put a tilde instead of the equal sign. Okay, so we have that there as well. It's saying this is true for all x. In order to put that constraint in there, I have to put x1 and then equals, as I said before, square bracket 1 dot dot 10. And then it says here a and b must be constants. When it says that a and b must be constants, There's nothing you have to really do in there for that. The SAT doesn't use imaginary numbers anymore, so we don't really need to worry about that. Regardless, it says, what is the value of AB? And so to find this at this point, we have A is being equal to 3 and B is equal to 4 there. So I can just put here AB, and that would give me 12 for the answer, which is the right one here. So that's basically all you need to do. And I think I actually have explanation down here. So there's a few things here that I'm going to have to say in the next stuff. But essentially, the steps to do the problem like this. So you turn the equation into regression, which you just do by swapping the equal sign for a tilde. And then if there's any x or y's, put x1 or y1. What I'm going to say next is how to stack them in brackets. So don't need to worry about that yet. And then finally, just add the constraints. And then this is typically all you need to do to make this work. This is pretty fine for questions like these, where you just have one equation. It gets a little bit more complicated when you have multiple equations, though. The thing you have to do with a problem like this is functionally the same thing, except now you have to stack them into brackets, like I'm showing here. Essentially, the way it works is you put the left sides of each equation and then the right sides of each equation over here. So left, left, and then right, right. A lot of students get confused when they see that for the first time, so try not to let that be you if you're seeing this for the first time right now. So if we have something like this, we have these two different equations. And also this works no matter how many equations you have. All that matters is if you have more than one, you have to start using the brackets. So just keep that in mind. So for this, I would take the left side of the first one, so u squared and then plus v squared, and then the left side of the second one. So I'm switching over to the second equation now, because that's, again, I'm doing like left, left, then right, right. So for this one here, I can do uv, again, tilde, and then I just do 4k, and then k minus 7. And it's asking us here, what is u plus v squared in terms of k? So in order to do that, I just have to put here u plus v squared, and we just see what that would be. And then it asks us which one of these is the same as u plus v squared, essentially. So I can try out each of these. I could do 2k minus 7. I could do 3k minus 14. I could do 4k minus 7. But none of those are matching with what we have up here for the u plus v squared. So we have to ultimately go to 6k minus 14, which would be 0.25 for the thing. So D is going to be the right answer here. It does also say k must be greater than 0, but I kind of just ignored that because k was already greater than 0. It's already 2.33, so it's not really that big of a deal. So that's the brackets thing here. It can also happen in brackets if you have even more than two equations, as I kind of just hinted at before. You just do it functioning the same exact way, where you put the left sides of every single equation, then tilde, then the right sides of every single equation. So this one here is kind of confusing. It says A, B, and C. They're selling it at prices P, Q, and R, and then says each of the thing costs 25. So okay, so each of these costs exactly $25. So you could basically think of it like we have an equation where this plus this plus this equals 25. This plus this plus this equals 25, and then the same for the last one. So in order to write that out, for the left sides of the equation, I would say 2, and then A corresponds to P, so 2P, plus 1 times, that would be Q, plus 3C, which would be R. So that'd be the first one. Then the next one would be 1P plus 3Q plus 2R. Then next one would be 4P plus 2Q plus 1R. And then finally, for the right sides, I would just do 25 3 times because each of those says must be equal to exactly $25. So 25, 25, and then 25. So if you understand what is actually going on here, you should hopefully be able to see how I'm getting each of these things. Essentially that equals that, that equals that, and then that equals that. So, okay, we have all that now, and it's saying what is the total cost of buying 1 unit of each product? So if we just say P plus Q plus R, that's 1 of each, would be 12. Now, one thing you might have noticed for this problem is that technically we actually did not need to use regression according to the rules. We actually had 3 different variables, but also 3 different equations. So essentially it's equal rather than one being greater. But I would honestly just say if there's ever more than 2 variables, meaning if there's 3 variables or more, you should just try using regression to solve it. You shouldn't even try using regular Desmos because while you could, it's going to just end up being really complicated. You're going to have to end up putting a constant in there, and there's all this other stuff that's going to happen. So yeah, that's another one here. And I could show a bunch more problems using this exact rule, but I want to show a few other things you might see with multivariable stuff. So there is something that can often appear where it's bringing a function into this. So still, it's the case where there's more variables than there are equations. You can see here, function f is defined by this. We have 1, 2, 3, 4, 4, I guess, different unknowns in only one equation. And it's also saying here f2 plus this. Okay, so I guess you could say there's, I guess you could argue maybe there's like four different equations here actually, but Yeah, I guess if you count these as equations. But regardless, we still, as I said in this problem, there's more variables than 2 in here. So we should still try to use regression to solve it. The way to use regression when you see something like this is you start out by just putting in the function. So I would just say f of x is equal to ax squared plus bx plus c. And then I don't add any sliders. It's going to tell me to add sliders here, but I'm just going to skip that. And then I just do the rest like normal, as I would from the other one. So I would do brackets, and I put the left sides of each of them. So I would do f of -2 for the first left side. Then the next left side would be f of 2 minus f of -2. Then the last one would be f of 3. And then for the right sides of each of them, it would be 16, then 12, then 22. Okay, so we have all of those different ones in there now. It's asking us, what is the value of f of 4? So as you'll notice here, it actually gives me what A would have to be, what B would have to be, and what C would have to be, considering this. Oh, wait, actually, wait, no, I actually, okay. It was actually just because I messed up this. Okay, f of 2 plus that. Okay, now it actually works like normal. So yeah, 32 is what I'm getting here, and that would be the answer for this problem. So it's just the same exact thing. The only thing is you have to add one more step, which is you have to put in the f of whatever function first of all. So that's one other thing you have to do. I'll show another example here where they're giving us this one, f of x equals mx plus b, and then saying some stuff. So yeah, equals mx plus b. Let me get rid of these again. Then I say, okay, it says f of 2p is equal to that. So brackets again, f of 2p. Then the left side, the next one is f of p plus 4. Then square bracket, and then the right side would be p plus 5, and then 2p minus 1. And then, yeah, we have that. It says p is a constant, and p cannot be equal to 4, and which one gives b in terms of p. So, yeah, we have this. Yeah, I think this is all fine. The one thing we might have to put in here. Oh, no, actually, I don't think so. So, yeah, it says, yeah, it just says p cannot be equal to 4, and it is not equal to 4 right now. It's saying, what is b in terms of p? When it asks something like this, what I can just go ahead and do is just type in each of these different things and just see which one equals b, essentially. So I could do it all the ones, but I think I know that either C or D is going to be the right answer. So let me just skip down to that. So 3p minus 5 is equal to -2. That is not 1. Then we have 3p squared minus 11p minus 20. And then divide that whole thing by p minus 4. And yeah, that would be equal to 9.333. So therefore, D is the right answer. If I tried A or B, it's also not going to be the right answer here. So same kind of thing. I just put in the function, and then I put in the actual brackets, and then we can get the answer through that. So this is the majority of what you really need to know. I pretty much guarantee you that most of the things you're seeing for constant problems are going to be exactly like this, solvable like this. Just use these 3 different rules and you can solve it. There is one other problem that I always see when I teach something like this, and people always ask me about it. So I feel like I might as well throw this in there as well, just so you don't get confused when you do see this problem. If they say something like the equation has no solution, and they ask, what is the value of k? You have to do it a little bit differently. Because if you think about what's really saying here, if I pull up Desmos, when you have no solution, as you probably know, it's something like this. You have like y is equal to 3x plus 5, and then like y is equal to 3x plus 8 or something. And it's essentially 2 lines where they never intersect each other a single time. For all the examples before, it was actually kind of like they did intersect at least one place. For this one, yeah, I guess like for this one, it's functionally like there's 3 different lines that all intersected one place. For this one, it's functionally like there's 2 different equations and they both intersect in one place. Most of these is like there are multiple lines and they're intersecting in one place. At least that's kind of what they're trying to say. So for this one, when they say here it's no solution, that basically is completely different from everything we've done already. And so you have to solve this a little bit differently. And actually, this is where I kind of have to put Desmos away for a second, because there's not really a good way, I think, to solve this with Desmos. Maybe there is, that I just don't know, but I currently do not know one. Think about, actually, let me bring out Desmos real quick again, just to show something. So think about what is really being shown here. When you have these 2 lines that have no solution, they have the same exact coefficient on x, but different values for the b here, or the constant, I could say. That's just what they must be. And that's exactly how I came up with this. If I change this, it's always never going to intersect if I just change that value there. So for this here, in order for it to have no solution, it functionally must be doing the same exact thing. Basically, what they're saying is that there's y is equal to 5 times kx plus 8, and then y is equal to 60 divided by 19x plus 25. That's really what we're saying here. It's saying here that they must have the same value for what is in front of the x, but a different value for what is over here. So with that information in mind, we can kind of piece together what must be the solution. So I'm going to bring in a little bit of math stuff here. So if I use the distributive property and use on that, we get here y must be equal to 5kx plus 5 times 80, which would be 40. So that's what we have there. And then we have for this one, y is equal to that's times x plus 25. So in order for this to be right, we have to have the same thing in front of the x, but then a different thing afterwards. So basically what we're saying here is that 5k must be equal to 60 over 19. That's what we must be saying. And also I made that 0 really small, so let me make that a bit bigger. Okay, so yeah, 60 divided by 19. So 5k must be equal to 60 divided by 19. Just to say it one more time, just so everybody understands what's going on here. So 5k, yeah, is equal to 60 divided by 19. Yeah, it's not really too much more I have to do there. I'll just put it into regression form. This is not really relevant to what I was teaching here, but yeah, it just makes it a little bit easier. So k must be equal to 0.631579. With that in mind, so yeah, we just have the value here. So 0.631579, because these things must be exactly the same. The only thing that must change is 40. So it doesn't matter that this is 40 and this is 25. We just know that this must be that. And if we want to check to make sure that this actually does work, we could put in here these two exact things. I could put here y is equal to 5 times, I guess, yeah, 0.631579x plus 40. And then we have here y is equal to 60 divided by 19 x plus 25. Now let's just make sure they never intersect each other a single time. So therefore, these would have no solution. There's probably a fraction that actually worked for that. I know there was, because that's what I was seeing when I was looking at the answer key before, but that's fine. So 0.631579. The one thing I will say, just to finish off with multivariable equations, is that there are a lot of different problems that they could theoretically show for these. Like I see new problems every single day with multivariable equations. This is kind of like what the SAT writers are really trying to figure out in terms of how to challenge students. Like how can they make new multivariable equation problems that are more difficult than the ones you've seen before. So there's constantly going to be new different types of problems coming out on the next SATs and the next SATs. So I can't give like every single problem you will ever see. Like there are even problems that I know of that are not shown here just because there's so many different types. But this is fundamentally the information you need to know. If you can use Desmos in this way, you'll be able to solve the majority of these, or at least figure out the way to solve these.